Hey there, this is Math 7, Unit 2, Lesson 5, looking at two equations for each relationship. We began today, first of all, looking at a series of missing figures, and you have figure 1, 2, 3, 4, and these ones are missing. And you look to see if there was a pattern going on here of some sort that helped you figure out what figure 1 and 2 are. One of the things I noticed is if I took a little line and cut that in half, I began with 2 large and 3 smaller, and then I flipped it to do 3 and 2. When I look over here at this pattern, I go 2 to 3, 3 to 2, 2 to 3. So it's like this kind of pattern, 2, 3, 3, 2, 2, 3, 3, 2, which tells me that the first shape most likely is going to be a 2 to 3 one, right? So it'd be like this, a 2, and then a 3, and that's be the first shape. And this third shape would be the first shape, and then I would still have the 1, 2, 3, that one, and then the third figure would add another one of these guys here. So 2 on the top, 3 on the bottom. The 10th figure, if I'm noticing here, the even ones would be very much like this. I'd have this one, the figure 2, and I would do that 5 times. So that when I got to the 5th figure, I'd have this set, 5 of those in a row, if I was to make that work out the right way. Alright, let's take a look at your lesson today then. We got to meters and centimeters, comparing how that works. We've talked before about converting from meters to centimeters, centimeters to meters. It's a nice way of doing those things, so multiply by 100. Pretty easy to do. So, because there are 100 centimeters in every meter, we can do this pretty simply. So to go from meters to centimeters, the conversion rate, or this, to do a constant, would be times 100, to multiply there. That becomes my, here's my x, my y, that becomes my y over x, which is 100 over 1. So my constant proportionality is 100. And in doing so, we also notice that when I multiply by 100, I'm just moving the decimal over. How many zeros there are? 2 zeros to the right. So this times 100 becomes 94, times 100 becomes 167, and times 100 becomes 5,724. And our last one here becomes 100 times x. To go the other way, we are multiplying by 1 over 100, which means our decimal point's hopping 2 spaces to the left. So we hop 2 spaces to the left, we have 2.5. 2 to the left means 0.782, and 2 to the left means 1.239. And then for our y value, we could either write it as 1 over 100 y, or if you want to write that as a decimal, it would be 0.01 y, so 100th y. Either one works just fine, depends on which one you want to play with there. So that's our table all completed. Your constant proportionality for each one, the first one is 100 and the other one is 1 over 100. And again, our key word is that these are reciprocal. Alright? They have the same, they both have a relationship between their constant proportionality that makes them connect together there. Alright, for each table, write the equation there. We did that already. And so our equation, write an equation for proportional relationships. So we would say that our length, so our y value, and this one equals 100x. So that's our first one here. And over here, this time here they changed it around to be y and an x. That's okay. We would say in this case here, our x equals 100th y. Okay? So that's how that would work if you did y and x that way, because they put a y in that column, switching things around. Alright, let's take a look at 5.3. So 5.3 is on filling the water cooler. And in this problem here, I think it's really important that you begin with some sort of table perhaps to help you understand the relationship here. So we've been playing with tables, so let's go ahead and make a table real quick. Alright, we have 2 columns here. And our first column, we're going to have, we say that it took probably 5 minutes to fill a cooler with 8 gallons of water from a faucet that was flowing at a steady rate. So we have water flowing at a steady rate. We know that we have water, okay, coming in. We have water, and that's going to be our gallons of water. And then we also have our time, and our time can be in minutes. Okay, so because these can go both directions, we want to write this down as gallons of water, and then yeah, gallons of water. And then we can also do it as the time in minutes compared to the gallons of water. So I can really write it two different ways. So in our first case, we know that she's doing at a rate of, we could say, 8 gallons of water. In 5 minutes, it took her 8 gallons of water flowed in there in a time of 5 minutes. Okay, so in this case here, this would be my x and my y value. So I'd have my time is equal to 5/8 times my water. So how long it takes to fill it up is going to be equal to my rate, 5/8 times the water. Now that 5/8 can also be written as a decimal if you prefer. So 5/8 is 0.625, and that's my water. Okay. Over here, if I have my time and I have my water, I could say that in terms of the time, it took 5 minutes to get me 8 gallons of water. So I would say that my W is equal to my constant proportionality, 8/5 times my T. This can also be written as a decimal, which would be W equals 1.6 times T. Excuse me. So what we're doing is we're saying, let's take the information we have, 5 minutes, 8 gallons, and let's write them up as two different charts, and we're going to change the charts around the order to create two equations. So now doing that, let's come back and say, well, what do I have? Do I have a W equals 1.6 T? Sure do. Do I have a W equals that? Nope, I don't. How about a T equals? Nope, my T equals 0.625. So in terms of my equations that work, I have them written here, and I have them written here. And I got those by using two different tables and turning the tables around like we did in previous lessons. So what does the 1.6 tell you about this situation? What does this number tell you? This tells us that the water is coming into the tank and there are 8 gallons, okay, where it's flowing at a rate of, so water's flow, the flow is 1.6, and in this case we have gallons as our top number per minute. So we have gallons per minute, because when we did this we had 8/5, and that's 8 gallons and a minute there. What does the 0.625 tell us? This tells us that it takes, in this case here, 0.625 minutes for 1 gallon to flow. Alright, so it takes 6.25 minutes for 1 gallon to flow. This is like our unit rate, right? So our unit rate. That's the difference there. This is telling how many gallons per minute. This tells how many minutes per gallon. So it's the reciprocal relationship there. Now it says that she changed the rate at which the water flowed through the faucet. Write an equation that represents the relationship of W and T when it takes 3 minutes to fill the cooler with 1 gallon of water. So we're saying it's 3 minutes per gallon, right? 3 minutes per gallon is what she's saying. So we look at our time, and our time is going to be the rate, 3 minutes for every gallon of water. So we're going to use the rate of minutes per gallon of 3 to find out how long that's going to take there. And the reason for that is that the 3, remember, is 3 minutes and 1 gallon. So I multiply it by a gallon value, okay, which we don't know what that is. That's our W value. Then the gallon terms cancel out and you're left with just the minutes, which is what we want because we're trying to find out the time that's going to be there. Okay, so that's one way of looking at it there. You could also then write another equation if you wanted to. You could say that if you want to go the other way, you do the inverse, and we would say that W equals 1/3 times T. Right? Why are we saying the inverse, the reciprocal? Because we're changing the terms around and we're making that the reciprocal value. So 3 to 1/3. So was the cooler filling faster before or after she changed the rate of flow? How do you know? Well, what we're comparing though is we're saying, well, I have a rate of 1.6 gallons per minute. That's my first rate here from 2. And over here, this is minutes per gallon. This one is my gallons per minute. This is 1/3 gallons per minute. So we're comparing it versus 1/3 gallon per minute. All right. So which one's faster? We would say that that one's going to be a greater, definitely going faster than 1.6 compared to 1/3 right there. Let's look at your next one. We have 5.4 on feeding the shrimp. It says that at an aquarium, shrimp is fed 1/5 gram of food each feeding and is fed 3 times a day. How much does food does a shrimp get fed in one day? So they're getting this amount and they're getting this 3 times. So times 3. All right? So that would be a total of 3/5 grams of food every day. That's how much one shrimp gets. So number of days multiplied by our constant proportionality, 3/5, tells us that in one day they get 3/5 food, 3/5 grams of food. After 7 days, we'd multiply again by the same rate, 3/5, to have 21/5, which can be reduced down to 4 1/5. And for 30 days, we multiply by 3/5 again, we end up with 18. So our constant proportionality is going to be 3/5 because that's the rate at which they're getting fed per day. If we switch the columns in the table, what would be the constant proportionality? Well, if we switched it, then we have to do the reciprocal. We would do 5/3, right? Reciprocal. That's why you end up with a different rate there if you change the columns around there. All right, and you could try that by actually doing it and doing the math. For 5, it says use D for the number of days and F for the amount of food in grams that a shrimp eats to write 2 equations that represent the relationship between D and F. Okay, so you might start off with the first one. You start off with, it's pretty straightforward. We can say, all right, D, number of days there, is going to be equal to, well, let's do it this way. Let's go what's in the table. The table we've talked about before, we have our X and our Y value, right? Our X and our Y, and in this case, our K value is 3/5. And we've said that one equation is Y equals KX. So if that's all true, then when we use that down here, we would say that Y, which is our food equals our constant proportionality, 3/5, times our X value, which they're calling D days. So one equation could be F equals 3/5 days. The other one then would be the reciprocal of that, our D would equal 5/3 times F. Okay? So it says a tank, using this, a tank has 10 shrimp in it. How much food is added to the tank each day? Well, we know that one shrimp gets 3/5. We're going to have 10 of those guys. So now we're going to have 30/5, which is going to be a total of 6 grams per day. That's how much they're going to get there. If the aquarium manager has 300 grams of shrimp food in his tank of 10 shrimp, so we're still the same number, 10 shrimp, and he has 300 grams, how many days is it going to last? Well, we're going to take those 300 grams, we're going to divide it by how many they need per day, 6 per day, and that will leave us with 50 days worth of food. We're going to take the 300 grams, divide it by how much the 10 shrimp need per day to leave us with the 50 days of food. So in summary, what we're talking about here really is that when two quantities, X and Y, are proportional in a proportional relationship, we can write it as Y equals K is K to X, K times X. And we can say it's there. We can also write the equation X equals 1/KY, and that's because it's the inverse there and there's still a corresponding constant of proportionality. And we can do whichever one we want depending on the information we have. So it depends on the information to decide which way you're going to go. Okay, let's pause there and we'll take a moment to do our homework. Okay, so looking at your homework for today, we have Unit 2, Lesson 5, 2 equations for each relationship. And so what we have is we have first a table, and it wants us to complete the table. And then we're going to write an equation for converting the number of meters to kilometers, and then we're going to use x for the number of meters shown. So first of all, we're going from 1,000 to 1. We need to determine what is that scale factor going to be, or what is going to be that constant what is that constant proportionality going to be. So we'd have, if this is my x and this is my y, I'm going to have 1 over 1,000, or 1,000th, okay, is what I'm multiplying by to make this take place. That's my k value. So to do that, then I'm multiplying by 1 over 1,000. If I wanted to write that down as 3,500 over 1,000 like that, I could. My zeros would then go away, and I have 35 over 10, right? 35 over 10 is what I'm left with there. And in looking at that, that becomes 3.5. The simple way is to look and say, I'm going to move it over 3 decimal places, 1, 2, 3, to have 3.5. So I'm going to do that on the following ones. Let's move over 3, 1, 2, 3. So we'll end up with 0.5. I'm going to move this one over 1, 2, and 3. So I end up with 0.075. And this one, 3, 1, 2, 3. Put my space holder zeros there. I have 0.001. And in terms of the last one here, I'd have 0.001x would be my equation that I would use to find out how many meters are in a kilometer. Okay, so that's what I would do there for number 1, parts A and B. Okay, looking at number 2, it says concrete building blocks weigh 28 pounds each. So the block weighs 28 pounds each. Using B for the number of blocks and W for the weight, write 2 equations that relate to 2 variables. Okay, what I want to do here is first I'm going to do blocks. I'm going to make a little chart. Blocks and weight. Okay, and here's what I know so far. I know that 1 block weighs 28 pounds. Okay, so having this information here, I can now write an equation, because my k value, my constant of proportionality, is going to be 28 to 1 when I write that out that way. And I could write down, remember my x and my y equals kx. So one equation that I could write could be W for the weight equals my constant 28 times the number of blocks there. That's the one thing that's already given. If I want to write the reciprocal of that, or the other equation, I would write the B equals, let's flip this, 1 over 28 times W. So those are my 2 equations that I would have. It's helpful, I find, to write the table real quick to make sure you know what you're working with. Block, weight, the given information there. Let's look at number 3. A store sells rope by the meter. The equation is P equals 0.8 L, represents the price in dollars of a piece of nylon rope that is L meters long. How much does a nylon rope cost per meter? That's like our unit rate, and that's going to be this value here. How much it costs per meter is going to be 0.8, or in our case, 80 cents. You could write that like so. You can write 80 cents, but it costs that much per meter. So how long is a piece of nylon rope that costs $100 okay, so if we look at our equation, if we have P equals 0.8 times L, right, that's how we started here, and I know that my price is going to be 1, so $1 equals 0.8 L. I can now solve for L by dividing both sides by 0.8, and 1 divided by 0.8 is going to be equal to 1.25. So my length of that rope would be 1.25, okay, or meters in this case, 1.25 meters. The table represents number 4, we'll look at number 4 on the next page. The table represents a proportional relationship. Find the constant proportionality and write an equation. So we want to find the constant and write an equation for this table right here. All right, so looking at our table here, our constant proportionality, we can look at any one we want to, but our constant would be 1 over 3, looking at a nice easy number to take a look at, right? It's that divided by that. I could do any one of them. I could do 4 over 12, but then I would still reduce that down to 1 over 3. So my constant proportionality in this table is going to be 1 over 3. My equation then would be y equals 1/3. Normally we say y equals k times x, but in this case, because they said we're dealing with an a, I'll put a into my place there and do 1/3 a. Okay? And let's take a look at number 5. Just look at a couple of these real quick. On a map of Chicago, 1 centimeter represents 100 meters. Select all the statements that express the same scale. So we've done this type of thing before, where we say, well, let's put them in the same type of scale. So if I have, to start off with here, 5 centimeters, it's already in the form centimeters. I have 50 meters, it's already in the form meters. And I would set that equal to 1 centimeter over 100 meters. If I multiply that out, I end up with 500, and then I end up with 50, and that's not going to work. Okay? When I look at B, B has 1 millimeter. Well, 1 millimeter is the same as multiplied by well, not multiplied by 10, I multiply by 1 over 10 because I'm going to centimeters. So 1 millimeter is equal to 0.10 centimeters. And then on the bottom I have 10 meters already, so I have the right unit. I multiply that by 1 over 100. Okay, so 100 times 0.10 moves over 2 places. Is going to be, that's going to be 10, and 10 times 1 is 10. That's going to be equal, so B would work. And then for C, it says that C is the correct answer in the answer document there. I've been playing with it a little bit, and just for some reason I just can't wrap my head around it for some reason. That's okay, it happens sometimes. If I was to do the same kind of conversion, I just don't end up with it equaling the same proportionally. Because 1 kilometer is the same as 100,000 centimeters, and 10 centimeters on a map, if I'm turning that into meters, is going to be 0.10. Okay, so that there is just not going to quite work out too well. Okay, that's how many meters that is. And when I make this equal to 1 over 100, I end up with, and again, my answer is not going to be correct here. 1, 2, 1, 2, 3, 1, 2. I end up with that crazy number equal to 0.10, which it's clearly not. So I had a question about this one here. So maybe ask your teacher how that's going to work, because the answer key does say it works. I just can't quite get it for some reason today. Some days my brain's working, some days it's not. So ask a question. That's a great one to ask about. On this last one here, the units are the same. So if I had my 100 centimeters over 1 meter and set that equal to my scale 1 centimeter over 100 meters, I can look quickly and say that's not going to work, because that's going to be 10,000 equal to 1, not going to work there. So it's definitely B, it's certainly not A and D, and I have a question about C, but ask your teacher and see what they say. I could not set that one up the right way. I'm doing something wrong. Done it a couple times. That's okay. Have a great day, and see you next time.